Welcome back to my class in linear algebra. Today we will continue with finding the inverse of a square matrix using adjoint. And we are done with finding the inverse of 2 by 2 square matrix by adjoint. Today we will find the inverse of a 3 by 3 square matrix by using adjoint and determinant of a matrix. We take now an example. Consider the 3 by 3 square matrix B with entries in the first row 1, negative 1, 0, 2, 1, negative 1, 0, 2, 1. And by using adjoint, the inverse of matrix B denoted by B to the power minus 1 is given as follows. The inverse of matrix B, denoted by B to the power minus 1, is equal to the adjoint of matrix B multiplied by the reciprocal of the determinant of matrix B. And we start by finding the determinant of matrix B. It is a single numerical value associated with the square matrix B. And if the determinant of B is equal to 0, we stop and we conclude that the inverse of matrix B does not exist. To find the determinant of matrix B denoted by this absolute value notation, but it's not actually the absolute value of B because we do not have an absolute value of a matrix, but this absolute value notation is used to denote the determinant of matrix B. And if you have a 3 by 3 matrix, you can find the determinant of B of matrix B or evaluate the determinant of size of order 3 by 3 in 6 ways. That is, using any of the 3 rows or using any of the 3 columns, which add up to 6. 3 rows plus 3 columns, 6. There are 6 ways to find the determinant of matrix B. And each time, and for each way, you should get the same result. But if you have 0 entries in the given matrix, you evaluate the determinant of the given matrix in terms of that row or column containing 0 or 0 entries. And we have 0 in the first row or 0 in the first column, so it's easier to find the determinant of matrix B using the entries of row 1 where you have 0, or in terms of the entries of the first column where you have 0. I will find the determinant of matrix B in terms of the entries of the first row. And we start with 1. The entry 1 is multiplied by its cofactor, and the cofactor of 1 is given by negative 1 to the power the row number and plus the column number of this entry 1. And the row number of 1 and column number of 1 is 1 and 1. This entry belongs to row 1 and column 1. Thus, we raise negative 1 to the power row number of 1 plus the column number of 1, which is 1. And multiply that by the determinant that remains when you delete the first row, the row number of 1, and the first column, the column number of 1. And the determinant of the remaining entries is a determinant of order 2 with entries 1, minus 1, and 2, 1. And by the method of getting the determinant of order 2 or size 2, we use like cross multiplication. We multiply 1 by 1, or we write first the determinant of order 2 with entries 1, minus 1, 2, 1. We are done with the first entry in row 1. The second entry in row 1 is minus 1. And to this we add minus 1 multiplied by the cofactor of minus 1. And the cofactor of minus 1 is given by negative 1 raised to the sum of the row number and column number of minus 1. And minus 1 belongs to row 1 and column 2. So the row number of minus 1 is 1 and column number of minus 1 is 2. Hence we raise negative 1. Negative 1 here is the element minus 1 here. And the cofactor of minus 1 is minus 1 to the power 1 plus 2. Where 1 and 2 here in the sum are the row number and column number of minus 1 respectively. And this we multiply by the determinant that remains by deleting, after deleting row 1, the row where minus 1 belongs, and column 2, the column where negative 1 belongs. And the remaining determinant is a determinant of order 2 with entries 2, minus 1, 0, 1. And then we add the third element in row 1, 0. But since it is 0, there is no more need to find the cofactor of 0, because the cofactor of 0 multiplied by 0 would still be 0. And if you add 0 to this sum, the sum will remain the same. That means 0 has no effect to this sum. That is why it is easier to evaluate the determinant in terms of a row or column with 0 entries. And we simplify each term of this sum. And we start with negative 1 raised to 1 plus 1. That's negative 1 raised to 2 is positive 1. Multiplied by 1 is 1. And we evaluate this determinant of order 2 by sort of cross multiplication. 1 multiplied by 1 is 1. Minus, it's always minus. 2 multiplied by negative 1 is negative 2. And negative 1 raised to 1 plus 1 is negative 1 raised to 3. That's negative 1. Multiplied by negative 1, that's positive 1 plus 1. Hence, negative 1 multiplied by negative 1 raised to 1 plus 2 simplifies to 1. Multiplied by this determinant of order 2 by cross multiplication. We have 1 multiplied by 2 is 2. Minus 0 times negative 1 is 0. 2 minus 0 is 2. And we simplify. Negative times negative 2 is positive 2. Plus 1 is 3. Multiplied by 1 is 3. And 3 plus 2 is 5. Thus, the determinant of the square matrix B is positive 5. and positive 5 is not equal to 0. Thus, we conclude that matrix B has an inverse matrix. So we proceed to find the adjoint of matrix B. And by definition of adjoint of matrix, the adjoint of matrix B is the transpose of the matrix whose entries are the cofactors of the entries of the given matrix B. So C sub 1, 1 is the cofactor of 1. And the cofactor of 1 is negative 1 raised to the sum of the row and column number of 1. And the row number of 1 is 1, column number of 1 is 1. So we raise negative 1 to 1 plus 1. Multiply by the determinant that remains after deleting the first row and the first column. Delete the first row and the first column and you get this determinant of order 2 with entries 1, negative 1, 2, 1. And we simplify. Negative 1 raised to 1 plus 1 is negative 1 raised to 2. And square of negative 1 is positive 1. Positive 1 multiplied by this determinant of order 2. This determinant of order 2 is equal to 1 multiplied by 1 is 1. Minus 2 times negative 1 is negative 2. Minus negative 2, that's positive 2, plus 2. Next, we find the cofactor of the entry in the first row and second column of matrix B, or the cofactor of minus 1, denoted by C sub 1, 2. And the cofactor of the entry minus 1 in the first row and second column is equal to negative 1 raised to the sum of the row number and column number of negative 1. Multiplied by determinant of order 2 by obtained by deleting the first column and second, by deleting the first row and second column. If you delete the first row and second column, the entries that remain are 2, negative 1, 0, 1. And we simplify. Negative 1 raised to 1 plus 2 is equal to negative 1 raised to 3, and that's equal to negative 1. Multiplied by this determinant of order 2, 1 multiplied by 2 is 2. Minus 0 times negative 1 is 0. 2 minus 0 is 2. Multiplied by negative 1 is negative 2. Next, the cofactor of the element in the first row and third column of matrix B, and that's 0. We find the cofactor of 0 denoted by C sub 1, 3. C sub 1, 3 is The cofactor of the element 0, the element in the first row and third column, is given by negative 1 raised to the sum of the row and column numbers of 0, which are 1 and 3 respectively, multiplied by the determinant that remains after deleting the first row and the third column. And the remaining entries are 2, 1, 0, 2. We simplify. Negative 1 raised to 1 plus 3 is 4. Negative 1 raised to 4 is positive 1. Multiply by this determinant of order 2. 2 by 2 is 4. Minus 0 multiplied by 1 is 0. That's 4 minus 0 is 4. Multiplied by 1 is 4. We are now in the second row. C sub 21 is the cofactor of the element in the second row and first column of matrix B. And that element is 2. The element in the second row and first column of matrix B is 2. We find the cofactor of 2 denoted by C sub 21. The cofactor of 2 denoted by C sub 21 is given by negative 1 raised to the sum of the row number and the column number of 2, which are 2 and 1. 2 and 1. And we multiply this by the determinant that remains after deleting the second row and first column. Delete the second row and first column, and the remaining entries are negative 1, 0, 2, 1. We simplify. Negative 1 raised to 2 plus 1, that's negative 1 raised to the power 3, and it's equal to negative 1. Multiply by this determinant of order 2. 1 multiplied by negative 1 is negative 1, minus 2 multiplied by 0 is 0. So that's negative 1 minus 0 is negative 1. Multiplied by negative 1 is positive 1. Next, the cofactor C sub 22, the cofactor of the element of B in the second row and second column, and that element is positive 1. The cofactor of the element 1 is given by negative 1 raised to the power 2 plus 2. The row number of 1 is 2, column number of 1 is 2. Multiply by determinant of order 2 obtained by deleting the second row and second column of matrix B. And the entries that remain are 1, 0, 0, 1. And we simplify. Negative 1 raised to 2 plus 2 is equal to negative 1 raised to 4, and negative 1 raised to 4 is positive 1. Multiply by the value of this determinant of order 2. 1 multiplied by 1 is 1, minus 0 multiplied by 0 is 0. That's 1 minus 0 is 1. Multiplied by 1 is 1. Now, the cofactor of the element of B in the second row and third column, and that element is negative 1. And the cofactor of negative 1 denoted by C sub 23 is given by negative 1 raised to 2 plus 3. The row number of minus 1 plus the column number of minus 1. multiplied by determinant of order 2 obtained by deleting the second row and the third column. And the entries that remain after deleting the second row and the last column are 1, negative 1, 0, 2. We simplify negative 1 raised to 2 plus 3 is equal to negative 1 raised to 5. And negative 1 raised to 5 is negative 1. Multiplied by the value of this determinant of order 2, we have 2 multiplied by 1 is 2. Minus 0 times negative 1 is 0. That's 2 minus 0 is 2. Multiplied by negative 1 is negative 2. We are now in the third row. The cofactor of the element of matrix B in the third row and first column, and that element is 0. The cofactor of 0 is given by negative 1 raised to the row number of 0, which is 3, plus the column number of 0, which is 1. And we multiply this by the determinant that remains after we delete the third row and the first column. And the entries that remain are negative 1, 0, 1, negative 1. We simplify negative 1 raised to 3 plus 1 is equal to negative 1 raised to 4, which is equal to positive 1. And we evaluate this determinant of order 2. We have negative 1 multiplied by negative 1 is positive 1, minus 1 multiplied by 0 is 0. That's 1 minus 0 is 1, multiplied by 1 is 1. Next, the cofactor of the element of matrix B in the third row and second column denoted by C sub 3, 2, and that element is 2. The cofactor of 2 is given by negative 1 raised to 3 plus 2. The row number of 2 plus the column number of 2. Row number of 2 is 3, column number of 2 is 2. So C sub 3, 2 is negative 1 raised to 3 plus 2. Multiplied by determinant of order 2 obtained by deleting the third row and the second column. And the entries that remain are 1, 0, 2, negative 1. Again, we simplify. Negative 1 raised to 3 plus 2 is equal to negative 1 raised to 5. And that's equal to negative 1. Multiplied by the value of this determinant of order 2, we have negative 1 multiplied by positive 1 is negative 1, minus 2 multiplied by 0 is 0. We have negative 1 minus 0 is negative 1. Multiplied by negative 1 is positive 1. And finally, we find the cofactor of the element in the third row and third column. That's the last row and last column of matrix B. And that element is 1. We find the cofactor of 1 denoted by C sub 3, 3. The cofactor of 1 is denoted by C sub 3, 3 is given by negative 1 raised to the sum of the row number and column number of 1. which are 3, which are both equal to 3. And we multiply this by the determinant that remains after we delete the third row, the last row, and the last column. And the entries that remain are 1, negative 1, 2, 1. We simplify. Negative 1 raised to 3 plus 3 is negative 1 raised to 6, which is equal to positive 1. And we multiply by the value of this determinant of order 2. We have 1 minus 1 multiplied by 1 is 1. Minus 2 multiplied by negative 1 is negative 2. So we have 1 minus negative 2. And that's 1 plus 2 or 3. Now we write the cofactors of the elements of matrix B in this matrix and we get the transpose. C sub 1, 1 is 3. The entries of the first row are 3, negative 2, 4. Entries of the second row are 1, 1, negative 2. And the entries of the last row are 1, 1, and 3. And the transpose of this matrix is the adjoint of the given matrix B. We will get the transpose of this matrix and we will multiply each entry of the resulting matrix which is the adjoint of B by the reciprocal of the determinant of B, which is equal to positive 5. We now find the transpose of this matrix and the result is the adjoint of matrix B. And to get the transpose of this matrix, we write the rows as columns. The first row with entries 3, negative 2, 4 will become the entries in the first column of the transpose of this matrix. So the entries of the first column are the entries in the first row of this matrix, 3, negative 2, 4. And the entries in the second row of this matrix, 1, 1, negative 2, we write as the entries in the second column of the transpose of this matrix. The entries in the second column of this matrix, the transpose of this matrix are 1, 1, negative 2. And the last row entries we write as the entries in the third column of the transpose. 1, 1, 3 becomes the entries in the last column or third column. And this is the adjoint of matrix B. We multiply each entry of this adjoint of matrix B by the reciprocal of the determinant of B. And the determinant of B is 5. So its reciprocal is 1 over 5. We multiply the adjoint of matrix B by 1 over 5, and the resulting matrix is the inverse of matrix B, denoted by B to the minus 1. Hence, B to the minus 1 is equal to 1 over the determinant of B, which is equal to 5. Multiply by the adjoint of matrix B with entries 3, 1, 1. Negative 2, 1, 1. 4, negative 2, 3. We multiply each entry of the adjoint of matrix B by 1 over 5. 3 multiplied by 1 over 5 is 3 over 5. 1 multiplied by 1 over 5 is 1 over 5. 1 multiplied by 1 over 5 is 1 over 5. The second row, each entry in the second row multiplied by 1 over 5. We get negative 2 over 5, 1 over 5, and 1 over 5. And the entries of the last row, we multiply each entry of this last row, third row, by 1 over 5. We get 4 over 5, negative 2 over 5, and 3 over 5. And this is the inverse of matrix B, denoted by B to the minus 1. Now we check if this is correct by multiplying matrix B by B to the minus 1, and the product should be an identity matrix of order 3 by 3, or simply of order 3. To check, we find the product B times the inverse of B, B to the minus 1. The product should be the identity matrix of order 3, or size 3 by 3, with 3 rows and 3 columns. And this matrix B multiplied by the inverse of B, denoted by B to the minus 1. We multiply the first row by each column of B to the minus 1. We have 1 times 3 over 5 is positive 3 over 5. Plus negative 1 times negative 2 over 5, that's positive 2 over 5. So we have 3 over 5 plus 2 over 5, that's 5 over 5, plus 0 multiplied by 4 over 5 is 0. So we have 5 over 5, which is 1, plus 0 is 1. Next, we multiply the first row by the second column. We have 1 multiplied by 1 over 5 is 1 over 5, plus negative 1 multiplied by 1 over 5 is negative 1 over 5. So that's 1 over 5 minus 1 over 5 is 0, plus 0 multiplied by negative 2 over 5 is 0. We have 0 plus 0 is 0. Next, we multiply the first row by the third column. 1 multiplied by 1 over 5 is 1 over 5, plus negative 1 multiplied by 1 over 5 is minus 1 over 5. We have 1 over 5 minus 1 over 5 is 0, plus 0 multiplied by 3 over 5 is 0. We have 0 plus 0 is 0. Next, for the entries of the second row of the product, we multiply the second row of matrix B by each column of B to the minus 1. We have 2 multiplied by 3 over 5 is 6 over 5, minus plus 1 times negative 2 over 5, that's 6 over 5, minus 2 over 5, that's 4 over 5, plus negative 1 times 4 over 5 is negative 4 over 5. We have 4 over 5 minus 4 over 5 is 0. Next, we multiply the second row by the second column. We have 2 over 5 is 3 over 5, plus 1 times 1 over 5 is 1 over 5. We have 2 over 5 plus 1 over 5, that's 3 over 5, plus negative 1 times negative 2 over 5, that's positive 2 over 5. We therefore have 3 over 5 plus 2 over 5 is 5 over 5, or 1. Next, we multiply the second row by the third column. We have 2 over 5. We have 2 multiplied by 1 over 5 is 2 over 5 plus 1 multiplied by 1 over 5 is 1 over 5. We have 2 over 5 plus 1 over 5 plus 1 times negative 3 over 5. We have 2 over 5 plus 1 over 5 minus 3 over 5 is 0. And the last entries of the last row are obtained by multiplying the last row of this matrix B by each column of B to the minus 1. Multiply the third row by the first column. 0 multiplied by 3 over 5 is 0. 2 multiplied by negative 2 over 5 is negative 4 over 5. Plus 1 multiplied by 4 over 5, we have 0. 0 plus 0 minus 4 over 5 plus 4 over 5 is 0. The entry here is obtained by multiplying the last row by the second column. We have 0 multiplied by 1 over 5 is 0. Plus 2 multiplied by 1 over 5 is 2. So that's 2 over 5. Plus 1 multiplied by minus 2 over 5 is minus 2 over 5. We have 0 plus 2 over 5 minus 2 over 5 is 0. And the entry here should be 1. We check multiply the third row by the third column. We have 0 multiplied by 1 over 5 is 0. 2 multiplied by 1 over 5 is 2 over 5. Plus 1 multiplied by 3 over 5 is 3 over 5. Thus, we get 0 plus 2 over 5 plus 3 over 5 is 5 over 5 or 1. And since the product is an identity matrix of order 3, therefore we conclude that the matrix B to the minus 1 we obtain is the correct inverse of matrix B. We will now take more examples for getting the determinant of order 3. For another example, for evaluating the determinant, for evaluating a determinant using cofactors, we consider this determinant of order 4 denoted by D. This is a determinant of order 4 because there are 4 rows and 4 columns. Again, the easiest way to evaluate a determinant is in terms of any row or any column with the greatest number of zeros. And by inspection of this determinant of order 4, we have the greatest number of zeros, 2 in the third column and in the third row. So I will evaluate this determinant of order 4 using 2 ways and see if we will get the same result. And we should get the same result if we evaluate this determinant of order 4 in terms of the third column and in terms of the third row. We start with the entries of the third column. In terms of the third column, we start with the first entry in the third column from the top, 0. And again, if we multiply 0 by its cofactor, the result is 0. Therefore, there is no need to write 0 multiplied by its cofactor. And we actually start with the first non-zero entry in the third column, which is negative 1. And negative 1 we multiply by its cofactor, and the cofactor of minus 1 is given by negative 1 raised to the sum of the row number of negative 1 plus the column number of negative 1. The row number of negative 1 is 2 and the column number of negative 1 is 3. So we raise negative 1 to 2 plus 3. And we multiply this by the determinant that remains after deleting row 2 and column 3. If you delete the second row and the third column, the entries that remain are 2, negative 1, 1. We delete the second row. The entries in the next row are 0, negative 1, 1. And the entries in the last row are 1, 1, negative 1. The next entry is 0. But again, if we add 0 here and multiply it by its cofactor, the result is 0, and therefore it has no effect to the first term. So we skip the second 0 and we take the next element, the last element in the third column of the 2. And we multiply 2 by its cofactor. The cofactor of 2 is given by negative 1 raised to the row number of 2, which is 4. It belongs to row 4. Plus the column number of 2, it belongs to column 3, plus 3. Multiply by determinant that remains after deleting the last row and the third column. And the entries that remain are 2, negative 1, 1. 1, 0, 2. And 0, negative 1, 1. Now we simplify and we evaluate each determinant of order 3. Again, use a row or column with the greatest number of zeros. And this is negative 1 raised to 2 plus 3 is negative 1 raised to 5, which is equal to negative 1. Multiplied by negative 1 is positive 1. So this is simply positive 1 multiplied by this determinant is equal to this determinant of order 3. We evaluate this determinant of order 3 in terms of the first column or the second row. I will use the first column. In the first column, the first entry is 2. And we multiply 2 by its cofactor given by negative 1 raised to the row number of 2, which is 1, plus the column number of 2, which is also 1. We have negative 1 raised to 1 plus 1. Multiply by a determinant of order 2, the determinant that remains after deleting the first row and the first column. And the entries that remain are negative 1, 1, positive 1, negative 1. The next entry in the first column is 0. But again, if we add 0 here and multiply it by its cofactor, the product is 0. And add this to this number, the result is this number. That this 0 has no effect to this first term in the sum. So we skip 0 and we take now the last entry in column 1, which is 1 plus 1. Multiplied by its minor, given by negative 1. Raised to the row number of 1 is row 3, 3. Plus the column number of 1 is 1, column 1. And we multiply this by the determinant that remains after we delete the last row and the first column. And the entries that remain are negative 1, 1, negative 1, 1. Now we simplify this second term. Negative 1 raised to 4 plus 3 is negative 1 raised to 7, which is equal to negative 1 multiplied by positive 2 is negative 2. We multiply negative 2 by the value of this determinant of order 3. And again, we use a row or column where we have the greatest number of zeros. And we have 0 in the second column. We have 1 0 in the second row, 1 0 in the third row, and 1 0 in the first column. I will use the third row. And the first entry in row 3 is 0, but if we multiply 0 by its cofactor, the result is still 0. And if you add 0 to a second term, the result is the second term. That means 0 has no effect to the sum. So we skip 0 and we start with negative 1, the next entry in the last row. Negative 1, we multiply by its cofactor given by negative 1 raised to the row number of negative 1, which is 3, plus the column number of negative 1, which is 2. And we multiply that by the determinant of order 2 with remaining entries after deleting the third row and the second column. And the entries that remain are 2, 1, and 1, 2. And the last entry in row 3 is 1 plus 1 multiplied by its cofactor. Cofactor of 1 is negative 1 raised to 3 plus 3. Because the row number of 1 is 3 and it belongs to column 3, its column number is 3. So we multiply 1 by negative 1 raised to 3 plus 3. Multiplied by the determinant that remains after we delete the last row and the third column or last column, and the entries that remains are 2, negative 1, 1, 0. We simplify. We have negative 1 raised to 1 plus 1 is negative 1 to the power 2, and negative 1 squared is positive 1, multiplied by 2 is 2. Multiplied by the value of this determinant of order 2, we have negative 1 multiplied by negative 1 is positive 1. Minus 1 multiplied by 1 is 1. So we have 1 minus 1 is 0, multiplied by 2 is 0. Plus negative 1 raised to 3 plus 1 is 4. Negative 1 raised to 3 plus 1 is equal to negative 1 raised to 4, which is equal to positive 1. Multiplied by 1 is 1. And 1 multiplied by this determinant of order 2 is equal to this determinant of order 2. And this determinant of order 2 is equal to 1 multiplied by minus 1 is minus 1. Minus negative 1 multiplied by 1 is negative 1. We have negative 1 minus negative 1, that's equal to negative 1 plus 1 or 0. So the second term is 0. plus negative 2, positive multiplied by negative 2 is negative 2. We can write minus 2. This is negative 1 raised to 3 plus 2 is equal to negative 1 raised to 5, which is equal to negative 1. Multiplied by negative 1 is positive 1, and positive 1 multiplied by this determinant of order 2 is equal to this determinant of order 2. So we simply evaluate this determinant of order 2. We have 2 multiplied by 2 is 4, minus 1 multiplied by 1 is 1. So we have 4 minus 1 is 3. The next term is negative 1 raised to 3 plus 3 is equal to negative 1 raised to 6, which is equal to positive 1. Multiplied by 1 is positive 1. And positive 1 multiplied by this determinant of order 2 is equal to this determinant of order 2. So we simply evaluate this determinant of order 2 for this last term. And this determinant of order 2 is equal to 0 multiplied by 2 is 0 minus 1 multiplied by negative 1 is negative 1. So we have 0 minus negative 1. That's 0 plus 1 or 1. We simplify 0 plus 0. 3 plus 1 is 4. Multiplied by negative 2 is minus 8. Plus 0 plus 0 is minus 8. And this is the value of determinant D, a determinant of order 4. If you evaluate this determinant of order 4 in terms of the entries of the third row, we should get the same answer, minus 8. And we will try that out now. Now we evaluate the same determinant of order 4, D, now using the entries of the third row. In terms of row 3, we find the value of the determinant D, and earlier we used the third column. Using the third column, we get the value of D equals negative 8. And using the entries of the third row of D, we should get the same answer, minus 8. In the third row, the first entry in the third row is 0. But if we multiply 0 by its cofactor is 0. And if you add 0 to the second term, the result is the second term. And so 0 has no effect to the determinant, the value of the determinant D. So we skip 0 and we start with the first non-zero entry in row 3, which is negative 1. Negative 1, we multiply by its cofactor given by quantity negative 1 raised to the row number of negative 1, which is 3, plus the column number of negative 1, which is 2. And we multiply this by the determinant of order 3 obtained by deleting the third row and second column of D. And the remaining entries are 2, 0, 1, 1, negative 1, 2, delete the second column and third row. And the last row entries are 1, 2, negative 1. Plus the next entry in row 3, but the next entry in row 3 is 0. And if you add 0 multiplied by its cofactor, the product is 0. And if you add 0 to this term of the sum, the result is this term. The 0 has no effect to the value of the determinant D. So we skip this entry 0 and we proceed to the last entry of row 3, 1. Plus 1, we multiply 1 by its cofactor given by quantity negative 1 raised to the row number of 1, which is 3, plus the column number of 1, which is 4. Negative 1 raised to 3 plus 4. Multiply by determinant of order 3 obtained by deleting the third row and the last column, the fourth column. And the entries that remain are 2, negative 1, 0. 1, 0, negative 1. And 1, 1, 2. We simplify by evaluating each determinant of order 3. And negative 1 raised to 3 plus 2 is equal to negative 1 raised to 5, which is equal to negative 1. Multiplied by negative 1 is positive 1. Multiplied by this determinant of order 3 is equal to this determinant of order 3. Thus, for the first term, we simply evaluate this determinant of order 3. And because we have 0 in the first row, and in the second column, we can use either the second row, or we can use either the first row or the second column of this determinant of order 3. I will use the second column. In terms of the entries of the second column, the first entry in the second column is 0. But again, 0 multiplied by its cofactor is 0. And 0 has no effect to the other terms. If you add 0 to the other terms of the value of the determinant, the 0 has no effect. So we skip 0 and we start with the first non-zero entry in the second column, which is negative 1. And negative 1 we multiply by its cofactor, which is given by negative 1. Quantity negative 1 to the power. The row number of negative 1 is 2, plus the column number of negative 1 is 2. Negative 1 raised to 2 plus 2. Multiply by determinant of order 2 obtained by deleting the second row and second column. And the entries that remain are 2, 1, 1, negative 1. Plus the last entry in column 2 is 2. We write plus 2. And we multiply 2 by its cofactor given by negative 1 raised to the row number of 2 is 3. Plus the column number of 2 is column 2, 2. Multiplied by the minor of 2, which is a determinant of order 2 obtained by deleting the last row and the second column. And the entries that remain are 2, 1, 1, 2. And plus negative 1 raised to 3 plus 4 is negative 1 raised to 7, which is equal to negative 1 multiplied by positive 1 is minus 1. Minus 1, or we simply write minus the value of this determinant of order 3, and we can evaluate this determinant of order 3 using the last column, the second column, the first row, or the second row. And I will evaluate this determinant of order 3 in terms of the entries of the third column. And the first entry in the third column is 0. We multiply that by its cofactor, and it gives us the same 0. And if you add 0 to the other term of the value of this determinant of order 3, the result is that term, which means that 0 has no effect on the value of the determinant of order 3. So we skip 0 and we start with the first non-zero entry in column 3, negative 1. We multiply negative 1 by its cofactor given by quantity negative 1 raised to the row number of negative 1 which is 2 plus the column number of negative 1 which is 3. We write minus 1 multiplied by quantity negative 1 to the power 2 plus 3. Multiply by determinant of order 2 obtained by deleting the second row and the third column, and the entries that remain are 2, negative 1, 1, 1. Plus the last entry in the third column, 2. Multiplied by its minor given by quantity negative 1 raised to the row number of 2 is 3 and column number of 2 is 3. Negative 1 raised to 3 plus 3. Times the determinant of order 2 obtained by deleting the third column and the third row. And the entries that remain are 2, negative 1, 1, 0. We simplify each term by evaluating each determinant of order 2. We start with negative 1 raised to 2 plus 2 is negative 1 raised to 4 which is equal to positive 1 multiplied by negative 1 is negative 1. Multiply by this determinant of order 2, negative 1 by 2 is negative 2, minus 1 multiplied by 1, we get minus 2 minus 1 is negative 3. Plus, this negative 1 raised to 3 plus 2 is negative 1 raised to 5 which is equal to negative 1 multiplied by positive 2 is minus 2. Multiply by this determinant of order 2, we have 2 multiplied by 2 minus 1 multiplied by 1 or 4 minus 1 is 3. Minus negative 1 raised to 2 plus 3 is negative 1 raised to 5 which is equal to negative 1 multiplied by negative 1 is positive 1. Multiply this determinant of order 2 is equal to this determinant of order 2. So we simply evaluate this determinant of order 2. 1 multiplied by 2 is 2 minus 1 multiplied by negative 1 is negative 1. We have 2 minus negative 1, that's 2 plus 1 or 3. And the last term, we have negative 1 raised to 3 plus 3 is equal to negative 1 raised to 6 which is equal to positive 1 multiplied by 2 is 2. Multiplied by this determinant of order 2, we have 0 multiplied by 2 is 0, minus 1 multiplied by negative 1 is negative 1. We have 0 minus negative 1, that's 0 plus 1 or 1. And we simplify, we have negative 3 minus 6 is negative 9. And here we have 3 plus 2 is 5 multiplied by negative 1. Sorry, this is negative 3 multiplied by negative 1 is positive 3. Positive 3 minus 6 is negative 3. And this is 2 multiplied by 1 is positive 2 plus 3 is 5 multiplied by negative 1 outside is minus 5. And minus 3 minus 5 is minus 8. And the value of the determinant is negative 8, which is equal to the value we get when we evaluated this determinant of order 4 in terms of the third column. That means if you use any row or any column to evaluate the given determinant, you should get the same result. For your practice, please try the following exercises. Number 1, if it exists, find the inverse of each matrix and check your answer. For letter A, the matrix M is a 3 by 3 matrix. For letter B, the given matrix M is again a 3 by 3 matrix. And for each of these, you start by getting the determinant of matrix M and determinant of matrix M. And if the determinant is 0, you stop and you conclude that the inverse does not exist. If the determinant that you get is non-zero, is not equal to 0, you proceed by getting the adjoint of matrix N or the adjoint of matrix M. And the adjoint of the matrix you multiply by the reciprocal of the non-zero determinant. And you have the inverse of the matrix N or M, and you check your answer by multiplying N by its inverse denoted by N to the power minus N. Also for letter B, to check, multiply the matrix M by its inverse if it exists, denoted by M to the minus 1. And for A and B, if your inverse matrix is correct, the product should be the identity matrix of size 3 by 3. Number 2, evaluate D using a row and a column. D is a determinant of order 4. It has 4 rows and 4 columns. And you will find the value of D, this determinant of order 4, in 2 ways. First way, you use a row, choose any row, but the easiest way is to choose a row with the greatest number of zeros. And the second way, you choose any column, but again, the easiest way is to choose a column with the greatest number of zeros. And using a row and a column, you should get the same value of D. And that completes our lesson for today. If you have questions about the lesson today, please ask your questions in the comments below. Thank you for joining me in my class today in linear algebra.